Production professionals have used their favorite microphones, amps, follow spots, and even spike tape. But how much time have you given to what Ethernet switch you put into your rig? The following will provide a bit of a history on networking and a bunch of 4-letter words that perhaps you're not so familiar with to help you make an informed decisions before you buy your next Ethernet switch. Before digital was a thing, each production department built its own infrastructure. Sound guys had monster analog snakes, the video crew used a lot of specialized coax, and lighting data was carried either on multi-core or multiplexed analog systems. In the early 1990s, I was working at the country's largest broadcast facility where each department had its own cables and patch bays. At the end of the day, all of our work was pushed down one coax cable and amplified across the country for people to watch. The future concept of millions of individual viewers self-directing their own on-demand streams from a server farm halfway around the globe seemed very far-fetched. Then, just 2 years after the launch of the World Wide Web, the director of MIT's Media Lab, Nicholas Negroponte, published a book called Being Digital. He predicted, among other things, the demise of terrestrial analog HD TV in a theory called the Negroponte switch. Low bandwidth telephone communications would go through the air. Where higher bandwidth was needed, we'd move that data over to copper. Today, his predictions have become fact. My sole takeaway from Being Digital was his thought that all the specialized tools from each department would fade away and be replaced by a single computer. And all the specialized plugs, patch bays, and cables would eventually be replaced by Ethernet, even though the coax leaving the building would be replaced with a digital fiber. So let's unpack this digital technology and see, literally, how this is all possible. Understanding the individual bits and bytes can actually help you make a better decision about which product you should buy when you build your entertainment infrastructure. It was the mid-1990s when category cable and pen-based T being for twisted pairs, became the preferred medium of transporting digital data. On the ends of the wires were the recommended jack, or the ubiquitous RJ45, and patch bays began to look like this versus this. And in the early days, the glue that tied the networks together was a device called a hub, like this one. A simple electronic device that worked at the physical layer 1 of the OSI telecommunications model. These devices did not incorporate a processor. There was no gating or switching or flow control. Every bit that went into one port came out every other port. As networks grew, sending all data in every direction every time became unsustainable. So technology evolved to include a new multi-port network bridge called the switch. This device started to use the MAC address, or the media access control tables, to forward traffic at the data link layer, or layer 2 of the OSI model. That means that a message Bob has for Sue is not seen by Kay, and likewise, the communication between Kay and Bob is completely hidden from Sue. More advanced switches forward data based on information inside the third network layer, incorporating additional routing functionality at the IP level. These routers sometimes even send data to other networks using secondary mediums, like cable modems do. We can use Wireshark, the most common network packet analyzer, to show exactly what the difference is between a hub, working at layer 1, a switch in layer 2, and a router at layer 3, and beyond into layer 6, the presentation layer, and layer 7, the application layer, which are responsible for handling end-user protocols like Dante, MPEG, and SACN, all of which carry the art which we create. Highlighting this packet, I can see from the protocol column that this is in fact lighting data that uses the Architecture for Control Networks protocol. Expanding the packet details, the first data comes from the network interface controller itself, letting us know that 680 bytes, or 5,440 bits, appeared on the wire at such and such a time, and Wireshark gives us a little more statistical analysis of those bytes. The second grouping of data is at layer 2, data link information, such as the MAC address for the source and destination, and what to expect a little deeper into the packet to come. Here you can actually look at the bytes, and the dissector helps determine what is what. And if you want to get closer to what it would look like on a scope, choose the view option to show the bytes as bits. The next grouping of data is layer 3, the network layer, and we got a hint from above that these bytes are encoded using the Internet protocols, specifically version 4. Moving on, we get to layer 4, the transport layer, and the dissector tells us that what we're seeing is UDP, or the User Datagram Protocol. Here we see the source and destination ports inside the IP addresses, layer 3, which have already been resolved to the MAC addresses above in layer 2. The next grouping of bytes is all the way up at the application layer, and it has been identified as ACN. And diving a little deeper, we can highlight the unique identifier of the console that sent this packet, and see that it is in fact streaming ACN, Universe 1 with a priority of 100. Going deeper still, you can see the actual start code and each of the 512 data slots of Universe 1. Are you starting to see that the deeper you go into the packet, the more you learn about it? That means that the hardware that is analyzing this data must be very fast, because its main job is to only read as much of the packet that is needed to decide what to do with it, and then quickly send it on its way. Switch Fabric is designed to make these decisions at what we call wire speed, and that can be up to 10 gigabits per second. That's pretty snappy. But link speed is not the only factor you should consider when deciding what sort of switch is right for you. Sort of like in carpentry, there are all sorts of glues that you use depending on the job that you are doing. So with an Ethernet backbone being the glue that ties your production together, don't use a switch that's designed for an enterprise system when your prime application is an entertainment system. Pathway Connectivity builds the VIA line of switches in Calgary, Canada, specifically to meet the demanding needs of entertainment touring and architainment installations. You can trust that our hardware is robust and proven, and our management software gives you the tools needed to get the gig up and running quickly and keep it running for years to come. So what sort of management features are right for the production environment? This is where I introduce you to what I call the four-letter words of networking. EAPS, or Ethernet Automatic Protection Switching, offers you the security of lightning-fast switchover to a secondary link in the case of catastrophic failure on the primary link. This ensures that the data reaches where it needs to go right on time. RSTP, or Rapid Spanning Tree Protocol, gives you two levels of protection. Firstly, it blocks traffic on redundant links, preventing network feedback that will inevitably crash your network. And secondarily, it offers protection, similar to EAPS, in the case of failure on the primary link. IGMP, or Internet Group Management Protocol, really leverages the power of the switch's role within the network when using multicast protocols like Streaming ACN, Dante, or AES-67. VLANs, or Virtual Local Area Networks, allow you to segregate one network system, one production backbone, across multiple departments without fear of bottlenecks or IP conflicts. LLDP, or Link Layer Discovery Protocol, is spectacular at identifying what is plugged in where at the 10,000 foot level, even when you're using multiple VLANs. DHCP, or Dynamic Host Configuration Protocol, allows the switch at the very heart of your network to manage IP address leases rather than laboriously maintaining static IP tables for all your gear that comes and goes. Dante Strict Quality of Service is a simple on-off switch to configure several aspects of the network to account for packet loss, bitrate, throughput, transmission delay, availability, and jitter. PoE, or Power over Ethernet, administers wattage allocation and incorporates a simple one-button cold boot sequence for end devices. And bandwidth monitoring on each link helps you identify traffic hogs and aids in building a robust network that remains responsive. Trap and Convert is a patented feature of the VIA switches that convert network-unfriendly broadcast protocols like ArtNet to well-behaved multicast protocols like streaming ACN. Another feature you won't find on your average enterprise switch is an optional connection to the 6i Cloud for unified remote management. This software as a service offering has been designed specifically for system integrators. If any or all of this makes it seem like networking is hard, don't worry. Our Passcape management software makes configuring and monitoring the network easy. It is also the same tool used to manage pathports, vignettes, cognitos, choreos, as well as any connected RDM responders. Pathway Connectivity, a division of Acuity Brands, has been in the business of connecting entertainment systems since the mid-1980s. Trust us to know how it's done. We've been digital for years.